Hi, I'm Naveena. Welcome to the short video on mapping in computer organization and architecture. In the world of computing, understanding how data and instructions are stored and accessed within a computer's memory is crucial. So, in this lesson, we will learn about what is mapping or mapping processes in computer organization and what are the three types of mapping processes. So, what is mapping or mapping process? The transformation of a data from main memory to cache memory is referred to as mapping process. Mapping from main memory to cache memory is a crucial aspect of computer architecture. The main reason is cache memory is faster than main memory. So, mapping ensures that frequently used data is brought into cache memory. So, we can access the data from cache memory without any time delay. There are three types of mapping procedure: associative mapping, direct mapping, and set associative mapping. Associative mapping. In associative mapping, any block of main memory can be mapped to any block in the cache memory. There is no fixed mapping between specific cache line and main memory locations. This flexibility in mapping allows for efficient cache usage since any block from main memory can be placed in any cache line. It often involves the use of tags to identify which memory block is stored in a particular cache line. Associative mapping is more complex and typically requires additional hardware to compare tags, making it slower and more expensive but very flexible. And here is the advantages and disadvantages of associative mapping. High flexibility and efficient cache usage are the advantages of associative mapping because we can place any block of main memory in any cache line and there is no restriction between where we shouldn't store the data or where we should. Disadvantages: cost of hardware is high and complex tag comparison. The next one is direct mapping. Direct mapping is also known as one-way set associative mapping. And in direct mapping, each block of main memory is mapped to only one specific block in the cache. This mapping is based on a simple mathematical function like modulo, which determines which cache line will hold the data from a particular main memory block. Direct mapping is simple and cost effective, but it can lead to cache conflicts where multiple main memory blocks map to the same cache line, causing inefficient cache usage. Advantages of direct mapping: it's simple, cost effective, and faster cache access due to a straightforward mapping process. And disadvantages are there may be high cache conflicts and it has limited flexibility compared to others. The last type is set associative mapping. Set associative mapping is a compromise between associative mapping and direct mapping. The cache is divided into a set of lines or slots, and each set contains multiple cache lines, usually 2, 4, or 8. A particular main memory block can be mapped to any line within its associated set. The mapping is done using a combination of direct mapping and associative mapping, allowing for some complexity while still reducing cache conflicts compared to the direct mapping. Set associative mapping strikes a balance between complexity and flexibility of associative mapping and the simplicity of direct mapping. These mapping techniques are used in cache memory system to improve data access, speed, and efficiency. The choice of mapping procedure depends on the trade off between hardware complexity, cost, and cache performance requirements in a specific computer architecture. And here is the advantages and disadvantages of set associative mapping. Advantages: when we compare to other mapping process, set associative mapping is highly flexible and there will be less cache conflicts and less complexity. And the disadvantages are its hardware cost is high and it may not eliminate all the cache conflicts sometimes.